Hi, so ready to look at section 5.5, which we're going to look at graphs of sine and cosine functions. And then the next section, we'll look at graphs of the other trigonometric functions, right? So this section, we're just focusing in on two, sine and cosine. So first, I just want to kind of explore, how do we graph, y equals sine of x and y equals cosine of x, right? You can see that's objective one here. So what I put first here is just the unit circle, and something they just want to kind of wrap your head around is that we've used x and y a little differently here than with than the way it's described here in this function, right? So we've looked at like these ordered pairs, right? So this is in the form x comma y, but recall that the x coordinate here is actually cosine of some angle, right? We've looked at it as theta, also as cosine of t. And the y coordinate, remember, that's sine. So that's like sine theta or sine of t. All right, so we've looked at it a little differently. You'll notice here I also have, that we've also looked at, x squared plus y squared equals 1, being the equation of the unit circle. And we've used theta and t as our independent variable before. So now what we're going to do when we're looking at the function of sine and cosine, instead of using theta or t as our independent variable, we're going to use the typical independent variable x, right? That's typically used, like if you look at, like a quadratic function like f of x equals x squared, right? Whatever's inside of here, right? That's my independent variable. So we're going to put it in those terms. So then I have, recall that the coordinates on the unit circle provide us with values for cosine and sine for given angles. The x-coordinate refers to the value of cosine and the y-coordinate refers to the value of sine, right? So I have here kind of like a warm-up problem. So we're asked to find the terminal point P of x comma y on the unit circle determined by t equals 411 degrees. Round your answer to 2 decimal places, right? So remember that, cosine of t is equal to x and sine of t is equal to y, the y coordinate, right? So what this gives me is that cosine of 411 degrees. So if I use my calculator and round to 2 decimal places, you should get 0.63 here. And then for this guy, if you take sine of 411 degrees, you should get 0.78 rounded to 2 decimal places. Right? So then the point x comma y would be 0.63 comma 0.78. Right? So that is point P. Right. So don't forget when you're doing these, you want to make sure your calculator's in degree mode in this case. Right, so you'd go to mode, make sure we're in degrees, which I am, and then I can just take, cosine of 411 and sine of 411. Right, I can get those values. Right. So then now what I'm gonna do just to kind of kind of see what would the graph of cosine and sine look like. What we're gonna do is, you can see we're letting x be the independent variable. So what I did is, these are our angles, angle measurements from the unit circle. Here would be the x coordinate for cosine. And then here would be the y coordinate for sine, right? So for example, if I want to focus in on this row, right, then if I go back to the unit circle, we're looking at pi over 6, right, which is here. So you can see that the x value is radical 3 over 2, so that's cosine. And then the y coordinate is 1/2, so that's sine. That's the output for sine, right? So in other words, if I look at what's the cosine of pi over 6, that's radical 3 over 2. That's the output, right? And then if I look at, well, what's sine of pi over 6? That's equal to 1/2, right? So if I do this all the way through the unit circle for all of these known values, we can get these outputs, right? So, this is like a t chart, right, for both functions. And then what I did now on the next page is I plotted these points on a scatter plot, right? So this first graph here is a scatter plot of all of those points, right? So in other words, I let this be my x and this be like my y, and I just plotted these points, right? That's what we get. So you'll notice that we get this like pattern here, like this like wave kind of pattern, right? And then the second graph, what this is actually looking at, so this solid green line is actually, like y equals cosine x, the actual function graph. And you can see these are all the data points from the table, right? Just labeled, so you can see how they all fit on the function. And this goes on in these directions forever, right? It just keeps oscillating over and over again, right? It just keeps repeating. And then here's the same thing for sine, right? So one thing you'll notice about these graphs is that cosine and sine, the graphs are, pretty identical, exactly the same. The difference is that they're shifted to the right, right? So this point here on cosine is at the point 0, 1, where this top point is at pi over 2, 1, right? So it's essentially shifted to the right pi over 2 units. Sine is from cosine. So they're fairly identical. They behave very similarly, right? So then on the next page, have some characteristics of graphs of sine and cosine. So both sine and cosine, they both have a domain of all real numbers, -infinity to infinity. Their range are in between -1 and 1, so inclusive. And the period is 2 pi. Right? So the graph of sine of x is symmetric with respect to the origin. So that means sine of x is an odd function, right? So if you look at the if you look at the graph, right, you'll notice that we have like this almost like y equals x cubed kind of look, right? How it's symmetrical about the origin, right? So this is an odd function. Where if you look at cosine, so let me get rid of this drawing here. If you look at cosine, it's symmetrical about the x-axis here. If I fold it here, or excuse me, the y-axis. If I fold it on the y-axis, it'll be symmetrical. So this is an even function, right? So sine is odd, cosine is even, right? We already knew that those functions were, sine was odd and cosine was even, but now looking at the graphs, it just solidifies that, right? And then lastly, what I was trying to point out is that the graphs of y equals sine of x and y equals cosine of x differ by a horizontal shift of pi over 2, right? So you can see how, the points are just kind of shifted over pi over 2 units, right? So like, just another quick example is this point here, pi over 2. Notice, on sine it's at pi, right? Because this point shifted over pi over 2 units, right? So everything just got shifted over. Right? All right, so I just want to maybe graph a few things here, and it can help us be able to graph sine and cosine pretty easily. So if we just start by making our unit circle, and we can kind of use that as a basis, and labeling the points. So like this point here is the point 1, 0. This point here is 0, 1. This point is -1, 0, and this point is 0, -1, right? And if we label my angles, this would be like 0 or 2 pi radians. Here, this is pi over 2. This is pi, and 3 pi over 2, right? So then if I just make an xy axis, we can begin graphing these. So we'll let this be 1 and this be -1, and then we're going to go up by pi over 2 on the x-axis. So this would be pi, and then we'd have 3 pi over 2, and then 2 pi. So, looking at this, if I want to graph, let's say y equals cosine of x on the top one, then I'm looking at the x coordinates, right? So when in the unit circle, right? So when I plug 0 into x, I'm going to get 1, right? I'm looking here, so we get 1, we put a point, and then pi over 2, so I'm looking at this x coordinate, this would be at 0, and then at pi, I'm looking at the x coordinate for that, which would be -1, and then 3 pi over 2, look at the x coordinate, we get 0, and then 2 pi, again, look at the x coordinate, and you get 1, right? So if you plot these points, then we get that, right? Something like that. So let me just see if I can do this draw this a little better. Right. So then let me do the same thing, but for sine of x. So kind of starts out the same. So just labeling. Let's say this is 1, -1. Right, then focusing in on the y coordinate, like here, this would be at 0, right? 0, 0, and then pi over 2, the y coordinate is 1. At pi, the y coordinate is 0. 3 pi over 2, the y coordinate is -1, so it'll be down here. And then back at the point 1, 0, the y coordinate is 0. So if we kind of draw in the curve, we get something like this, right? Obviously, it would look better on graph paper, but I think that will do the trick, right? So then there's going to be a couple of things that we talk about on the graph that I want to label here. So we already talked about this term called a period, right? So this distance here is called a period, right? So within a period, that's going to be like the part where it's not repeated, right? So yeah, of course, there's a couple of parts, like this y coordinate at 0 is the same as the y coordinate at pi, which is the same y coordinate as 2 pi. But there's kind of like these two parts where we have this kind of like a hill and then kind of like a valley, right, if you will, with that. So as sine keeps continuing, it's going to keep going in this pattern, right? So like this would be another period, right? And then you keep having more and more of these periods. So you'd have another period this way too, every 2 pi. Right, so that's what we call a period. And then another term we need to introduce, which is essentially kind of like the height of a hill, if you will. Right, this is what we call the amplitude. Right, so from here to here is the amplitude. So notice it's kind of like it is half the distance between like the max and the min, right? So like if I look at this point and this point, here and here, I take the difference between those, the y coordinates, and then divide by 2, then that gives me the amplitude. Right, we're going to talk about the amplitude here coming up. So objective 2 is, we looked at just graphing sine x and cosine x, so now we're adding another part. What if we have like this, some constant a being multiplied out in front of the trig function? So notice that the graphs of both the sine and cosine function alternate between a relative minimum or maximum and x-intercept for each quarter of a period, right? So you can notice that each of these is a quarter of a period. The period here is 2 pi, so 2 pi divided by 4 would be pi over 2, right? So we added pi over 2 each time on the x-axis. So each quarter of a period, it alternated right between this relative minimum or max and also the x-intercept, right? So then this part here is just some review. It says recall from college algebra, and if you took college algebra at Ohio State, that was section 2.6, which is our current textbook that we're using for this class. That if you have a graph y equals a times f of x, that's the graph y equals f of x with the following, right? So it's going to be what we call vertical stretch if the absolute value of a is greater than 1, or vertical shrink if the absolute value of a is in between 0 and 1, right? And then if a happens to be negative, that's going to cause a reflection about the x-axis, right? So like, for example, if you had like y equals 2x squared versus y equals x and y equals negative x, right? Those graphs are going to look, very different, right? So we could look at a website called Desmos. And just, show that really quick, right? So like if I had, y equals x squared. Let me grab my keyboard for this. It'll be a little easier. Oops. Hang on. Keyboard's not talking to my surface. Excuse me. So y equals x squared. And then we're going to look at, y equals 2. Let's do like 4x squared. So notice, what happened. The red line is just y equals x squared. And if I put a 4 in front, we had like a shift, right? Where if I put in like 0.25 x squared, what's going to happen is it gets wider, right? So it's going to be a vertical shrink, right? It's kind of like pushed down, right? And then the other one we were going to look at was like y equals negative x squared, right? So since it's negative, we get that reflection about the x-axis, right? So that's just like a quick exercise to go over just to refresh you of that, right? So, it's pretty similar. We're still looking at a function. Those things are still going to apply, right? So for the graphs of y equals absolute value of a sine of x and y equals absolute value of a cosine of x, the value of the vertical scaling factor, absolute value of a, is called the amplitude of the function, right? So the amplitude represents the amount of deviation from the central position of the sine wave. The amplitude is half the distance between the max value of the function and the minimum value of the function, right? So that's what I was pointing out in that diagram, right? So like for these guys, like when we just have y equals sine of x, right? I could put a 1 in front, so that's the amplitude, right? Which works, right? Because the distance between 1 and 0 is just 1, right? So that height of the hill, if you will, is 1. Right. All right, so let's work through an example. So what we want to do is graph the function and identify the key points on one full period, right? So part A, I have the function y equals 2 cosine of x, right? So let's start by just making a t-chart. Right, so with these, it's pretty typical to use 0, pi over 2, pi, 3 pi over 2, and 2 pi, right, to get one full period. And as we mentioned, if you split the period into forts, these are some key points, right? So then I'm just going to draw the unit circle really quick up here as a reference. Right. So if I plug these values into 2 times cosine of x, right, this would be, y equals 2 cosine of 0, which is equal to 2 times, so cosine of 0 would be the x coordinate, which would be 1, right, of this point. So 2 times 1, which is just 2. Oops, I guess I don't need that line. All right, so then, y equals 2 times cosine of pi over 2 would be equal to 2 times, so cosine of pi over 2 would be this x coordinate, which is 0, so that's just 0. And then we'd have y equals 2 times cosine of pi. So cosine of pi would be -1. Right, so again, I'm just looking at the x coordinate, right, for pi. So 2 times -1 is -2. And then this would be y equals 2 times cosine of 3 pi over 2, which would be equal to 2 times, so cosine of 3 pi over 2 would be 0, which is 0 here. And then lastly, we'd have y equals 2 times cosine of 3 pi over 2, cosine of 2 pi, which would be 2 times, and then we'd be looking at this x coordinate, which is 1, so we get 2, right? So in other words, we get 0, pi over 2, pi, 3 pi over 2, and 2 pi. Right, so I can make this t-chart. I'll make this a little cleaner. So this would give me 2, 0, -2, 0, +2. Right. All right, so let me I'll just erase this table because it's going to be in the way for part B anyway. And I'll draw the graph here in its spot. So that's why I wanted to draw that cleaner version. So notice my y values go in between 2 and -2. So I'll label those. There's my y values, my x-axis here, and then my standard be going up by pi over 2 each time. I just need to plot these points, so we'd be at 0, 2, pi over 2, 0, pi, -2, 3 pi over 2, 0, and 2 pi 2. And then I can graph the curve. So we got like these hills. We get something like that. Right, so in this case, the amplitude is 2, right? The amplitude is this value here. So the amplitude is 2, and just to make that clear, that's this distance here, right? Also this distance and this distance, it's like the height of the hills, or the depth of the valley, if you will, right? So that's 2 units, right? So then if I look at part B, right, this tells me a couple of different things. So if I look at this amplitude, right, this negative sign, the negative sign tells me that it's a reflection about the x-axis. And so A is negative 1/3, right? So since A is negative, I have a reflection about the x-axis. Then the absolute value of A is equal to the amplitude, which would be the absolute value of negative 1/3, which would be 1/3. Right, so in this case, the amplitude is 1/3. Right. So if I make a XY T chart, right? So we can plug in these values and solve for y, right? So here we would have y equals negative 1/3 times sine of 0. Right, so if I look up at my unit circle, I'd be looking at 0 degrees, and the y-coordinate would be 0. Right, so this would be equal to negative 1/3 times 0, which is just 0. Pi over 2 would be y equals negative 1/3 times sine of pi over 2. So sine of pi over 2, right, that's the y-coordinate, so that would be here, which is 1. So this would be negative 1/3 times 1, which is negative 1/3. And then we'd have y equals negative 1/3 times sine of pi, which is equal to negative 1/3 times. So sine of pi would be this y-coordinate 0. So that's just equal to 0. And then we'd have y equals negative 1/3 times sine of 3 pi over 2, which is equal to negative 1/3 times. So sine of 3 pi over 2 would be this y-coordinate here, right? So negative 1, which is equal to positive 1/3. And then lastly, we'd have y equals negative 1/3 times sine of 2 pi, which is equal to negative 1/3 times. So the y-coordinate would be here for 2 pi, so that's 0. Which equals 0, right? So those are my points I need to plot. So let me make an XY chart here. So since my amplitude is 1/3, right, I'll put 1/3 here and negative 1/3 here. And then I'll put 0, pi over 2. Whoops, we don't need to label 0. Pi over 2, pi, 3 pi over 2, and 2 pi. So there's my x-axis, my y-axis. So now I can just plot these points. So we have 0, 0, pi over 2, negative 1/3, pi 0, 3 pi over 2, 1/3, and then 2 pi's back at 0. And then if I just draw in the curve, we get this graph, right? And this goes on forever, right? Right. Just that we were asked to graph one full period, right? So in between here, here, and here, that's one period. Right? And don't forget, just graphically, right? This part here is the amplitude. All right. So we keep adding more and more pieces to these functions, right? So we've talked about amplitude so far. So now we want to talk about what happens if we have some value being multiplied inside the function, right? So you have like, objective 3, graph y equals a times sine of b times x, right? So the bx is the input, right? So so what I have here, recall from section 2.6 that the graph of y equals f of bx is the graph of y equals f of x, but with a horizontal shrink or stretch now, right? So the factor of b will affect the period of the sine cosine, right? Because it's going to like pull it or smush it together, right? So for y equals a sine bx and y equals a cosine bx, where b is positive, the amplitude and period are blank, right? So let's fill that in. So the amplitude, we already know to be equal to the absolute value of the a value, right? So then it turns out that for sine and cosine, the period then, what that's going to be equal to is a typical period, 2 pi, divided by whatever that b value is. Right? So then notice I said that b has to be greater than 0. So the question is, what if b is negative? What would happen then? Right? So let me write down some things here. So let's say, let's let b equal to negative b when b is less than 0, right? So in other words, we're saying that b is just the variable b by itself is always positive, and if I write negative b, that shows that b is truly negative, right? So if I have y equals a times sine of negative bx, this would be equal to so sine is an odd function, right? So this would be equal to negative a sine of bx, right? So this is since sine is odd, right? But if we look at a cosine of negative bx, this would give me just a cosine of bx, since cosine is even, right? So cosine of negative bx is just the same thing as cosine of bx. So you can see that this doesn't impact the period then, right? So since cosine and sine are odd and even, that's going to impact the amplitude, if it's reflected about the x-axis or not, right? Like we just looked at in the last objective. So in other words, if we have a negative b value, we can rewrite it using properties of odd and even functions with sine and cosine. All right, so I have another example to look at. So example 2 is we're given that f of x equals 2 times sine of 4x. We want to be able to identify the amplitude and the period. And then next we want to graph the function, identify the key points on one full period, right? So, the amplitude, remember, is equal to the absolute value of a. So in this case, the a is here, a equals 2, right? And then this 4 value, right? Remember, that's the b value, so b is 4. So amplitude is equal to the absolute value of a, which would be the absolute value of 2, which is just 2, right? And then the period, remember, is equal to 2 pi divided by b, which would be 2 pi over 4 in this case, which that just reduces down to be pi over 2, right? So then let me just write something here. So, to get the key points, maybe interval, I'll call it that. In order to get those, what you're going to end up doing is you're going to take the period and divide it by 4, right? So this, in this case, would be equal to pi over 2 divided by 4, which would be equal to pi over 8, right? So pi over 8 is what we're going to end up wanting to add each time, right? So when I come down here and I make my XY t-chart, right? Along the x, I'll start at 0, and what I want to add now is pi over 8, right? So we'd have pi over 8, and then add another pi over 8 would be pi over 4, and then another pi over 8 would be 3 pi over 8, and then lastly pi over 2, right? So notice what I'm ending at is what one full period would be, right? Between 0 and 2 pi would be one period. Right? So then now I just need to plug these values in. So f of 0 would be equal to 2 times sine of 4 times 0, which would be equal to 2 times sine of 0. Right, so if we think about the unit circle, right, here would be 0 degrees. So the y-coordinate of this point, this black dot, would be 0, right? So this would be equal to 2 times 0, which equals 0. Right, so then pi over 8, we would have, f of pi over 8, which would be equal to 2 times sine 4 times pi over 8, which would be equal to, this would be 2 times sine of pi over 2, right? Sine of pi over 2 would be the y-coordinate here, which would be 1. So this would be 2 times 1, which is 2. And then f of pi over 4 would be equal to 2 times sine of 4 times pi over 4, which would be equal to 2 times sine. So that would just reduce down, right, to be just pi. So sine of pi would be here. The y-coordinate would be 0, so this would be 2 times 0, which is 0. And then f of 3 pi over 8 is equal to 2 times sine of 4 times 3 pi over 8, which would be equal to 2 times sine of, so that would end up being 3 pi over 2. Right, so sine of 3 pi over 2, right, we'd be looking at this point here, the y-coordinate, which would be -1. So this would be 2 times -1, which is -2. And then lastly, pi over 2. So we would have, f of pi over 2 would be equal to 2 times sine of 4 times pi over 2, which equals 2 times sine of, so 4 times pi over 2 would be 2 pi. So we're looking at the y-coordinate here at this point, which would be 0. So this would be 2 times 0, which is 0. All right, so if we want to begin to graph this, so let me just fill in my x values, right? So 0, pi over 8, pi over 4, 3 pi over 8, pi over 2. And then along the y-axis, let's see, my amplitude was 2, so we just need, between -2, or that would be +2, excuse me, and -2. And then we can plot my points, so we have the point 0, 0. Whoops, I don't know why I drew 0 on the axis here. Let me fix that. There, right? We want this point to be the origin, right? My bad. I think I just wrote it down because I wrote it down in the x, table, so just out of habit. So we would have 0, 0, the point 0, 0, and then pi over 8, 2, and then pi over 4, 0, and then 3 pi over 8, -2, and then pi over 2, 0. So then we can just graph this. And we get a graph that looks like this. Right, so notice that this period is shorter than 2 pi, right? The period's pi over 2, so it's going to keep repeating itself. In this case, it will repeat itself 4 times in a typical period, right? All right, so now we're ready to add in yet another step into this, which is, notice what we're adding now are these variables c and d, right? So we only got to graph the function y equals a sine of bx minus c plus d, and y equals a cosine of bx minus c plus d. So recall that if you have a graph y equals f of x minus h, that's the same graph as y equals f of x, but with a horizontal shift of absolute value of h units, right? So if h is less than 0, it shifts to the left. If the h is positive, it's going to the right. So these graphs may have both a change in period and a horizontal shift, right? And then you should note that the plus d at the end, that's going to be a vertical shift up or down potentially, right? So we're just adding in these possible shifts to the graph, right? So we looked at the parent function like y equals sine of x and y equals cosine of x, and what we've been looking at are some different transformations that can happen in those graphs, right, to get all other graphs of cosine and sine. All right, so let me label some things, right? So these are some properties of the general sine and cosine function. So some of the stuff we already know. So the first thing is that the amplitude is going to be equal to the absolute value of a. The phase shift is going to be equal to c divided by b. So this is something new, right? The phase shift is just another term. It's essentially the horizontal shift. Right? And then let's see, we already knew the period. Period, remember, was 2 pi over b. And then the vertical shift, as I pointed out, will be equal to d. And then if we want to find one full cycle given on an interval, this is what we'll have to use. So one full cycle is given on the interval (0 less than or equal to bx minus c less than or equal to 2 pi. Right, so if we plug in the bx minus c part into that, then we can solve for x and find out what the full cycle interval would be. Right, and then the domain we know will be negative infinity to infinity. And then the range, to figure that out, you're going to use this inequality. So we would have negative absolute value of a plus d less than or equal to y less than or equal to absolute value of a plus d. Right, so we just need to solve that, and we could figure out the range. Right. So now that we know that, let's see, I have 3 more examples to look at, and then objective 5 we have 1 more example to look at, and then we'll be finished up with this video. Right, so let's look at example 3, which is we want to look at the function y equals cosine of 3x minus pi over 2. So we want to identify the amplitude and the period. Right. So, looking at this, if I put a 1 in front of here, right, that means that a is equal to 1, b is equal, we could put a plus 0 at the end too, right? So my b value is going to be 3. My c value is pi over 2, and my d value is 0 then, right? So I can, just fill in all these parts. So the amplitude is equal to the absolute value of a, which would be the absolute value of 1, which is just 1, right? The period, recall, is equal to 2 pi over b. So that would be 2 pi divided by, so b is 3. Right, so we get 2 pi over 3. The phase shift is equal to c divided by b, which would be equal to pi over 2 divided by 3, which this would be equal to pi over 6. Right, because you could multiply top and bottom by a third. Right, just division of fractions, right? And then it didn't ask us to find this, but one thing I want to find, like we did before up here, these key points in the interval. Let's go ahead and find that, right? So we just want to take the period divided by 4. So this would be 2 pi over 3 divided by 4, which would be 2 pi over 12, which is pi over 6. Right, so then in part B, we want to graph this now, right? So I'd want to start at 0, and I'm going to go up by, pi over 6 each time, right? And if I wanted to, something we could do is use this interval. So we have 0 less than or equal to bx minus c less than or equal to 2 pi, right? So the bx minus c for us would be 3x minus pi over 2. Right, so then if I want to solve for x, right, I could add pi over 2. So what we get is pi over 2 less than or equal to 3x less than or equal to, so 2 pi plus pi over 2, that would be, 4 pi over 2 plus pi over 2. So that would end up being 5 pi over 2, right? And then now I'd want to divide everything by 3. So we end up with pi over 6 less than or equal to x less than or equal to, so this would be what, 5 pi over 6. So this would be the typical period for cosine. Right, so instead of starting this at 0, we could start this at pi over 6. And then what I'm going to be adding each time is what this guy was, which the period divided by 4, which was pi over 6. Right? So from here to here, we're going to add pi over 6. So that gives me pi over 3. And if you wanted to think about it as 2 pi over 6, we could. So then next would be, 3 pi over 6, which would be like, pi over 2 reduced down. So then 4 pi over 6 would be 2 pi over 3. And remember, we want to stop at 5 pi over 6. Right, so 5 pi over 6 doesn't reduce down. Right, so we added pi over 6 each time. So then, filling this in, we'd have y equals cosine of 3 times pi over 6 minus pi over 2. So this would be equal to cosine of, so 3 times pi over 6 would be pi over 2, right, minus pi over 2, which gives me cosine of 0. Right, so cosine of 0 is equal to 1. Right? If you forget that, right, here's my unit circle. So I'm looking at 0, which would be this point here. So that's the point 1, 0. And cosine is the x-coordinate, right? So we would be at 1. It'd equal 1. So then next we would have, y equals cosine of 3 times pi over 3 minus pi over 2. So this would equal cosine of, so 3 times pi over 3 would be 1. It would be pi, right? 1 pi. So we'd have pi minus pi over 2. So you have 1 pi minus a half a pi, so that's just cosine of pi over 2. Right, cosine of pi over 2 would be here. Right, this is pi over 2. That's the coordinate 0, 1. So the x-coordinate is 0, so that's what the cosine is equal to. So this would be equal to 0. Right? So then next we'd have, y equals cosine of 3 times pi over 2 minus pi over 2. That's equal to cosine of 3 pi over 2 minus pi over 2, which is equal to cosine of pi, which is equal to, so cosine of pi, I would be here now, right? That's the point -1, 0. So that would be, cosine is the x-coordinate, so that would be -1, right? And then we would have, for the next one, y equals cosine of 3 times 2 pi over 3 minus pi over 2, which would be equal to cosine of, so 3 times 2 pi over 3 would be 2 pi, so minus pi over 2, which is cosine of 3 pi over 2. Right, so now we are here. That's the point 0, -1. The x-coordinate is 0, so this would be equal to would be equal to 0. And then lastly, we have y equals cosine of 3 times 5 pi over 6 minus pi over 2, which would be equal to cosine of, so 3 times 5 pi over 6 would be what, 5 pi over 2 minus pi over 2, which is equal to cosine of 2 pi. Right, so now we're back at the point 1, 0. So cosine is the x-coordinate, so this would just be equal to 1. Right, so we have this t-chart filled in for this function. So now we want to graph it. So I ran out of room, so I'll just come over here and graph this. Right, so let's see, we had 5 pi over 6. Right, and then we were in between 0 and 1. Right, so here's 1, here's -1. So if I plot these points, let's see, for pi over 6 we had 1, pi over 3 was at 0, pi over 2 is -1, 2 pi over 3 was 0, 5 pi over 6 was 1. Right, so that's one period of this cosine function, right? That's the typical period. And we identified those key points. All right, so we're at 56 minutes. So I think I'm gonna I'll stop here, and then the next half of this video will won't be nearly as long. So I'll make a part B, right, for this section. So make sure you let me know if you have any questions. Thanks.